Hello everyone. Today I will help you guys to solve the problem 8.35. Having this circuit having two sources, two switches, one dependent source, one capacitor, one inductor. The question they ask us to find the voltage of right here and the current of the inductor right here. Okay, so we have two positions. Okay, when like t at 0, the switch at this position, and this switch is at this position. When t more than 0, the switch open, and this switch open. Okay, so first of all, we have to find the initial value of voltage of capacitor and initial value current I of this inductor. Okay, so the initial value, that means that at t less than 0. Okay, so at t less than 0, this switch at this position. Okay, so there is no source 8 volt. Okay, let me redraw the circuit. Okay, but at the initial value, because it's closed long time ago, so this capacitor open circuit will behave as open circuit. Okay, so this is V, and we have the resistor here 2 ohm. This is 12 volt. Okay, and this switch also is closed at this position. Okay, and we have the independent source right here equal V1 over 2 ampere. This is V1, and we have 3 ohm here. And the inductor right here behave as short circuit. Okay, right here. So look at this circuit. We see at this node connect to ground right here. So that means the voltage right here equal 0. That's VL right here equal 0. Okay, and VL right here, that's equal VL right here. Also equal the voltage right here is VL. Okay, everything right here equal 0. Okay, so everything, the voltage right here 0, so everything 0. Okay, so now we have to find the voltage, initial voltage right here. So I'm writing the voltage equation for this loop. I call this the current I. I call this one the current I. Okay, so I got the equation is 12 volt plus V plus 2I. Okay, plus 2I equal 0. Hold on, plus V1. Okay, plus V1 equal 0. Oh, we can call it plus 2I, 2 current 2I. Okay, equal 0. But we know this is open circuit, so the current right here equal 0. So that means the I right here equal 0. Okay, so that means 12 volt plus V plus 0 equal 0. So that means V equal 12 volt. So that means V at t equal 0 equal V at 0 plus equal 12 volt. Okay, and I already say at the beginning that the voltage right here go to ground, so the current, everything voltage right at this not equal 0, so that means the current I L right at initial value equal 0. Okay, that means equal I 0 plus. Okay. Now, the state at t less than 0, we already found it, voltage and current. Now we checking at t greater than 0 at the switch open, go to another position. Okay. So t more than 0, the circuit of us have to go, the switch have to go this way, no more 12 volt source. Okay. So we draw A1 here, connect to capacitor. At this time, the voltage and the current change, everything change, because go to this short from 12 volt to 8 volt, so everything change. So that means that the voltage and the current go to the capacitor, everything change. So at this time, capacitor get the voltage from A source. Okay, so it's working. Okay. So 110 farad here, 2 ohm here, and at this time this switch open. This switch open, so the current cannot go through. Okay. This is V1 over 2 ampere here. This is 3 ohm here, and the inductor acting right now. Okay, current I right here. This is 1 Henry. Okay. So because no current go to here, so this circuit separated. Okay, we have two circuits here, one circuit here, one circuit here. So look at this one. Because this right here V1. So this over here, this short right here is dependent short here, V1 over 2. So we have to find out V1 to find the current I right here. Okay. So I call this the first circuit 1. This is second circuit. Okay. Check the first circuit. I write in voltage equation right here for this loop. So I got negative A plus V plus V1 equal 0. But V1 equal 2 ohm time with the current. Current I go to here and go down here. Okay, 2I. Okay, but we know this is the current I go to the capacitor, but we know the current I equal C dV dt, but C equal 110 dV dt. So that means VI equal 2 times 110 dV dt. That means equal 1/5 dV dt. Okay. The V1. Okay, this is V1. Okay. So replace over here. So we got negative A plus V plus 1/5 dV dt equal 0. Okay, so I time both sides for 1/5. Time for 5. I'm sorry. I got negative 40 here, plus 5V here, plus dV dt equal 0. I replace, changing position. Okay, I put dV dt in the front. dV dt plus 5V equal 40. Solve for this differential equation. I got V equal A E minus 5t over here plus 40d divided by 5 here. So I got V equal A E minus 5t plus A. Okay, but I have to find the constant A. To find the constant A, I'm using initial value of V to find the constant A. But I know that initial value of V equal 12 volt. So that means that V at 0 equal 12 equal A plus A. Okay, at T equal 0. Okay, so that means A equal 12 minus A equal 4. So the V, the voltage we have is, here is 4 times E minus 5T plus A. Okay, that's the voltage of V. We found it. Now, we need to find the V1 right here. We need to find the V1 right here. So to find the V1, because we have dependent source is a V1 over 2, so we need to find V1. So look at this look at this equation, what I have right here to find V1. Okay, V1 equal A minus V. Okay, so that means V1 equal A minus 4E minus 5T minus A. So that means V1 equal minus 4E minus 5T. Okay. Now we got V1. Now we take a look. We're working on the second circuit. Okay. So the current at this one, I tie them up, equal 1 node. Okay. So we know that the sum of the current go in equal sum of the current go out. So this is current go in. Okay, I write note equation right here. V1, the current right here, V1 over 2. But before I write note equation, I have to find the voltage right here to get the current right here. Okay, so the voltage right here, that means the voltage of equal the voltage of inductor. But the voltage of inductor equal what? Equal, we know the VL equal L di dt, right? That we have the formula of this one. But L of us is 1. So that 1 di dt, that's a VL. VL right here is equal VL right here, equal VL voltage right here. So I'm writing no equation, okay? But V1 over 2 equal VL. That means di equal VL. I write that VL divided by 3 plus current I. So that means V1 over 2 equal di dt divided by 3 plus I. So that means that V1 over 2 what equal 1/3 di dt plus I. So I simplify this one. Okay, I time both sides for 6. Okay, so what I got 3V1 equal 2 di dt plus 6I. Now I time both sides for 1/2. So what I got? 3/2 V1 equal di dt equal plus 3I. So, but we know V1 equal negative 4E minus 5T. So I bring this one right to here. Okay, so I got 3/2 times minus 4E minus 5T equal di dt plus 3I. So this one equal negative 6E minus 5T equal di dt plus 3I. I solve for differential equation, okay? Like di over dt plus 3i equal negative 6e phi t, okay? So to solve this equation, I time both sides for e3t. So I got e3t di dt plus 3e3t I equal minus 6 e phi t times e 3t. So look at this one. This one, that means that the derivative of e 3ti, right, equal negative 6 e minus 2t. I take integral both sides. So I got e 3ti equal, okay, negative 6 divided by negative 2, right? E minus 2t plus c. Okay, so that means that I divide both sides for 1 e 3t. So I got that I equal 3 e minus 2t divided by e 3t plus c e 3t. Okay, so that means I got here current I equal 3 e minus 5t plus c e minus 3t. Okay, to find c, I have to use the initial value of current IL. Okay, so I know the initial current value of IL is equal 0 when I saw it at the beginning. Okay, 0. Okay, so I of 0 equal 3 plus c. Okay, so that means c equal minus 3. So the current I fact is 3e minus 5t minus 3e minus 3t. And so this is my final answer of the current of inductor, and this is okay, and my final answer of the voltage of a capacitor. Let's to check with we get the correct answer or not. Let me check in the book. Okay, this is the problem 8.35. Here A35 here. We got 4e minus 5t plus a. What we got here? Let's see. 4e 5t plus a volt here. Okay, this is voltage. How about the current? The current we got 3e 5t minus 3e 3t. What we got here? Three e minus 5t minus 3e 3t. Okay, so we got everything. Okay, we got the correct answer. If we compare our answer with the answer in the book, okay, this is A35 right here. The problem A35. Okay, A35. Okay, so hope you guys understand what I'm doing, what I did. And if you guys have any question, just comment me, okay? Thank you.